video, I want to show you two examples of how to use integration by parts to compute integrals. First, I just want to review, what does integration by parts say? You're given an integral that's a product of some functions of x. You think of one of those functions as being u of x, and the rest of the integral, the rest of the function of x together with the dx, think of as dv. The integral of u dv is then equal to u times v, u of x times v of x, minus the integral of v du. So this works really well if the integral of v du is simpler than the integral you started with, the integral of u dv. So I've written some version of this up here because this is a really important takeaway. Integration by parts works well if you have one function that gets simpler when you differentiate it. So u to du gets simpler. And then dv to v, one function that doesn't get much worse when you take an antiderivative. So it's maybe too much to ask for to say that you want your function to get simpler, but you don't want it to get way, way, way worse. So let me show you what I mean with an example. So x to the fourth natural log of x dx. Natural log of x, when you differentiate, you get 1 over x, which is definitely simpler than natural log of x. So that's a good candidate for our function u that gets simpler when you differentiate. X to the fourth, an antiderivative is 1/5 x to the fifth. That's not simpler than x to the fourth, but it's not a lot worse. So let's try setting u equals natural log of x and dv equals x to the fourth dx. So then du is 1 over x dx, and b is equal to 1/5 x to the fifth. So what does integration by parts say? This integral we started with is equal to u times v, natural log of x, times 1/5 x to the fifth, minus the integral of v du, 1/5 x to the fifth, times 1 over x dx. And this integral is much simpler than the one we started with. Rewriting a little bit, we get natural log of x times x to the fifth divided by 5 minus 1/5 times the integral of x to the fourth dx. And we know the integral of x to the fourth. We can just pick our simplest antiderivative. Let me write this over here. So altogether, we get natural log of x times x to the fifth over 5 minus 1/5 times 1/5 x to the fifth. You can combine the denominator to be 1 over 25, and then we get a plus c. And what are we saying? We're saying this function is an antiderivative of x to the fourth times natural log of x dx. And you can check. What I mean is take d dx of this function To do that, you'll have to apply the product rule to this first part. You'll have natural log of x times 5x to the fourth over 5 plus 1 over x times x to the fifth over 5. And everything is going to cancel in such a way that what you're left with is x to the fourth times natural log of x. So this is our first example. And I'm going to pause and then show you another example of a sort of different kind. Let's look at an example with a trig function. Let's take the integral of x times cosine of x dx. So remember, what we're looking for is a function that gets simpler when we differentiate. That'll be u. And the rest of the function, dv, which is whatever is left over, shouldn't get much more complicated when we take an antiderivative. So the derivative of cosine is negative sine. That's not simpler than cosine. But the derivative of x is just 1. So that's definitely simpler. So let's try and see what happens when u equals x. then du is just equal to dx. So the rest of what's left over, dv, should be cosine x dx. And then v should be any antiderivative of cosine x. So let's just take sine x. So where does that leave us? Now integration by parts says that this integral is equal to u times v, x times sine of x, minus the integral of v du, which is sine of x dx. Sine x dx. So what does that mean? Well, we get x times sine of x, and then we know an antiderivative of sine of x is negative cosine of x. So what we get in the end is plus cosine of x plus c. So let me say, same thing, you can check. D dx of x sine x plus cosine of x plus c is equal to x times cosine of x. Where does this come from? You apply the product rule to the first part. You get derivative of x, which is 1 times sine of x, plus x times the derivative of sine of x, which is x cosine x, plus the derivative of this, which is minus sine of x. So the plus sine of x cancels. The derivative of c is 0. So we've found an antiderivative of x cosine of x using integration by parts.